So I'll be showing you how to match a polynomial to a polynomial description. All polynomials can always be rewritten in the form of by listing out all their factors and can possibly have a scale factor that is being multiplied. A scale factor is any real number that is multiplied to the whole equation. The roots, also known as x-intercepts or zeros, can be listed in the form x equals 1, 2, 3, 4, whatever the roots are. And they can be listed as factors by just taking x and subtracting it from the root. The number of factors depends on the degree of the polynomial or function. So for example, if you have a polynomial of degree 5, then that means that you will have 5 factors. Let's take a look at an example. If we were to find a function of degree 3, so it's telling us what the degree is, the degree 3, and it has the roots of x equals 6, x equals negative 4, where the root x equals negative 4 has a multiplicity of 2. So we can actually rewrite this all as a factored function. Remember that if our root is x equals 6, then to rewrite this as a factor, we have to take x and subtract it from the root, which is 6. So our factor is just x minus 6. Our other root, which is x equals negative 4, we can do the same thing. So we could take our x and subtract it from negative 4. But a negative minus a negative, that's just x plus 4. So to rewrite this as a function, we can actually just write our function as a list of all its factors. So the description does not say that there is a coefficient or anything being multiplied, so we don't have to worry about the constant multiple. So we can just list out the factors. So one of our factors was x minus 6, and the other was x plus 4. And it also says that it has the root at x equals negative 4 has a multiplicity of 2. What that means is that there are 2 of the same factors. This can also just be rewritten as x minus 6 times x plus 4 squared. So this is our function of degree 3 with roots x equals 6, x equals negative 4, where x equals negative 4 has a multiplicity of 2. Let's take a look at another example. If we were asked to determine a function f of x with leading coefficient negative 2 of degree 3, having roots of x equals 2, x equals negative 2 minus 5i, and x equals negative 2 plus 5i. So we can do something similar to the previous example, where we list out the leading coefficient multiplied by all the factors. But first, let's rewrite the roots as factors. So our first root is x equals 2. We can rewrite this into a factored form by writing x minus the root, which is 2, and similarly can be done with the other ones. So for x equals negative 2 minus 5i, we can rewrite this as x minus our root, which is negative 2 minus 5i. And the same thing can be done for the other one. So our other root is x equals negative 2 plus 5i. So we're going to do exactly the same thing. We're going to rewrite it as x minus negative 2 plus 5i. And these are our factors. The reason why I'm writing the roots inside parentheses is because if we wanted to simplify, and in this case we do because we cannot have i's in it, when we simplify, we want to distribute the negative inside the parentheses because it is being subtracted from the whole root. So we know it has to have this form. So in this case, our leading coefficient is negative 2. So that means that our c is negative 2. And now by listing out the factors, our first factor was x minus 2, and the second factor was x minus negative 2 minus 5i, and then our third factor was x minus negative 2 plus 5i. And since we have a degree of 3, we do have 3 factors, so that makes sense. But since we can't have any i's in our final function, we're going to want to simplify this a little bit. Since we can't have I, let's just go ahead and simplify this inner part that has the i's. So we're going to want to distribute in the negative signs. And that's going to just change the signs of the inside. So we're going to have x minus negative sign, negative is a positive, plus 2 plus 5i times x plus 2 minus 5i. So all we did is distribute the negative signs. So since we still have I, we're going to want to keep distributing the x to the x to the 2, and the x to the negative 5i. And the same thing for the 2. We're going to want to distribute 2 to the x, 2 to 2, and 2 to negative 5i. And the same thing for 5i. We're going to distribute 5i to x, 5i to 2, and 5i to negative 5i. So x times x is x squared. X times 2, that's positive 2x. X times negative 5, that's negative 5xi. And then 2 times x, that's positive 2x. 2 times 2, that's plus 4. 2 times negative 5i, that's negative 10i. And positive 5i times x is 5xi. 5i times 2, that's positive 10i. And 5i times negative 5i, that is negative 525i squared. So simplifying this a little bit, we can cancel out 5xi's and the negative 10xi. So combining like terms, we get x squared plus 4x plus 4 minus 25i squared. But remember that I squared is actually the same thing as saying negative 1. So this is the same thing as saying x squared plus 4x plus 4 minus 25 times negative 1. Simplifying this, we just get x squared plus 4x plus 29. So our final function is negative 2 times x minus 2 times x squared plus 4x plus 29.